Hello, everyone. This is JEM Technologies. Thank you for coming to our presentation. And this is our Ticketing Consolidation Program. I'm Jonathan Jardine.
I'm Ethan Faber. I was primarily in charge of doing the software portion of our project.
And I am Matt McLean.
On the agenda today, we have a few topics. The first thing we'll be talking about is our project background. Then we'll be moving on to our solution approach. Then the system review, our budget, some of the challenges and the lessons that we learned during this project, the conclusion, and then finally some recommendations on what we would add or change if we had the project again.
So for the project background, I conducted an interview with IT consultant firm. It was Longview Systems. And in the interview that we had, they mentioned that there's a couple options for some projects that they were not really actively looking for, but something that would definitely be beneficial to the service desk at Longview. One of those was a consolidation program for ticketing systems. Since Longview does use multiple ticketing systems based on what clients they actually do work for, and they would like a centralized location for being able to access said tickets instead of having to go into each environment for each client, which obviously takes time. So that is where the project came from. We decided to take on this project with hopes that an easy to implement system would be able to be created, which we will move on to in our presentation here.
So the solution that we decided on trying to approach, the issue is that it's a web-based database for all these ticketing systems, so each one is stored in a different area. We had to bring them all together into a single view for our GUI. And then this way we'd have users, or more specifically employees that would be from said Longview. They'd log into a centralized location so they could view the tickets that were created from multiple different areas, but it's just in one single area. To achieve this, we needed to create multiple client environments that would hold the databases. But we ended up doing we had one database that held all the tickets that we would gather from all the different ticketing sites. So we would pull the data from there, transfer it into our database, so then we could modify it, change it, and display it in a way that we deemed we needed.
So starting off with our system review here, we'll be talking about the hardware. Our hardware was pretty limited considering we virtualized most of what we were using. So our hardware was essentially running about 5 to 7 VMs, and the 2 desktop computers we were using were just standard Windows 10 desktops. One was a client machine, and then one was a company machine that was acting as a simulator for clients of Longview sending in tickets from their own systems. And along with that, we also had one Raspberry Pi. This Raspberry Pi was initially wanting to create a IDS on Snort with the Raspberry Pi. Unfortunately, the Raspberry Pi does not have the system requirements capable of running Snort, so instead we made a network analyzer with that instead. And this simply just analyzed incoming and outgoing connections to and from our company computer. And now we'll move on to the next section here.
So I will be going over the security aspect of our project. So for the security aspect, we had obviously user accounts that would be able to access the environments through RDS and the ticketing systems themselves. So each of those user accounts, we actually implemented a password complexity that included length, password history, and 90-day expiration date. So for some of the portions of the complexity as well, needed to be at least 8 characters long, including a uppercase, lowercase, and a number, and the possibility of a special character as well. So some of the other features that we included for our security were firewalls, which were configured on both client and company machines to only allow connections to ticketing systems on validated systems. There was non-essential services on RDS servers that have been disabled due to limit security holes. And then we did have company servers on a private network, which can only be accessed through a secure VPN connection.
So a review of what we did for the software, we ended up breaking it up into two different areas. So we had a backend program which would actually scrub the data off the websites to get the tickets, and this was coded with Python. The main functionality behind it was it just made comma separated value files, and that would then be imported into PHP MyAdmin. And then this would in turn create the actual tables used. And then for our front end program, we started with a GUI that would have been Python, but we figured it would be easier. We ended up coding it in HTML with CSS and PHP. It displayed all the information from the database that would be moved in with the backend program, and through this you can search it and just kind of find tickets that you need, and it would hold ServiceNow and Hesk, because that's the two ticketing systems we decided to do this project with. We could have done more, and it's just that's how we tailored our software around, so it was designed specifically for these two ticketing systems.
So now I'll be talking about the networking for our system. So initially we wanted to do a physical network involving a switch between our two computers. However, that had a few security issues along with it, and we decided that it just wasn't the best option when we were using a bunch of VMs. So instead we decided to do two virtual networks instead. And so we had two networks that could connect to each other. There was one on our client network and one for the company network. And again, these networks were privatized with a VPN, so only secure access was allowed, just again to limit any security holes. And for our firewall and VPN, we decided to use pfSense. Initially, we were using Windows Defender, which is standard firewall rules. However, we found that pfSense was a lot more configurable and secure for what we wanted to do with our system. And now moving on to the next section.
So for the server services that we had installed on our servers, obviously Active Directory was one of the main features just for creating user accounts, obviously setting up the domain that could be accessed through RDS. DHCP obviously provided dynamic IP addresses to the client machine and the company machine. We did have a DNS server incorporated in there as well. The remote desktop services was up there along with the AD in terms of something that was extremely needed in our project, just to allow the two separate networks to be able to talk to each other and be able to remote in from one network to the other network. And then we obviously had our WAMP server, which housed our databases, which controlled those. And then we did have to set static IP addresses on our servers themselves. But again, for the client machines, we did incorporate the DHCP for that.
So for what we anticipated for assets that we'd use in our budget, we thought we would use our school laptops with us rather than we ended up renting machines, but we thought we'd use our laptops that we've been going through school with. We also thought we'd have a wireless access point and a firewall, which we did have. But then we also anticipated having an additional desktop and maybe some extra peripherals to go along with it, such as like keyboard, mice, monitor, just simple stuff. And we calculated it to come out to about $5,680. And now moving on to the actual cost.
JEM Technologies' Ticketing Consolidation Project went through a few changes with its hardware and assets throughout the course of the semester. And this is just due to either power system requirement issues or just optimization for a project. For example, as you can see here, we use desktops instead of our laptops, just considering our laptops, were very underpowered for the amount of VMs that we needed. So in the end, we ended up using two desktops, as I just mentioned, one for the company system and one for the client system. A wireless access point just to act as an intermediate between the two separate networks. Firewall, which was just implemented as a VM, which was again pfSense as mentioned before. Desktop, and then more peripherals, which just include mice, keyboard, monitors, all that stuff. And our actual assets did end up costing around the same, $5,680. Just ended up being even, although there was a few differences within the anticipated and actual assets. And that concludes our budget.
So the other portion of our budget was the man hours or the labor that was anticipated. So we originally thought that the three of us would be paid around $60 an hour over the course of 4 months, which would include 40 hours of work per week. So that amounted to $38,400 each for a total of $120,880. So that's what we originally anticipated, and Ethan will go over the next slide here for the actual labor costs, which was drastically different.
So for actual labor, we kept what we were being paid at the same. It was $60 an hour. That was what we just kind of estimated. It only lasts about 3 months because our time kind of got cut a little short with some holidays and other unexpected events. We only did, like before, we anticipated like 40 hours a week full time, but that's obviously not possible with doing full time school, and we have jobs on the side. We did about 20 hours of work per week, so we calculated that out to about $14,440 each, and ultimately that came out to be $48,880. So it's about a third of what we anticipated for what we would be using.
So, of course, as Ethan was mentioning, there was a few obstacles that we faced during the course of our project. There were some challenges and also some lessons we learned from that. Obviously, a major challenge that we encountered at the end of the project was the COVID-19 pandemic. We were unable to fully complete our project due to the situation, and unfortunately, we also couldn't really virtualize our project. It just didn't really cater to that. We did acquire a lot of the hardware that we couldn't access from the lab that was closed down. On the bright side, though, we were able to create a working software program that demonstrated the software aspect of our ticketing consolidation program. And this was nice because it acted kind of separate from the hardware and gave us an opportunity to demonstrate how the tickets were consolidated into a single view. Along with that, just lessons we learned, a lot of the stuff was just involved in configuring RDS and all that. We kind of had underpowered machines at the beginning, and we weren't really running at full optimization there. So we just had to kind of take a step back and reevaluate what we were using, how we were approaching the situation. And we'll get Matt to talk about the next topic here.
So for recommendations with our software was pretty static in terms of how it functioned. It could have been a lot more dynamic. Because we had the comma separating value backend program, moving the files it would create into the database, you had to modify the field names for the columns so that they would meet a certain criteria, and because of that, like, that's obviously not super dynamic. You want it to be able to pick up things how they are and just display them, but that's how we got it to work. But another thing, a big part of it was all of this was manually done, so we would need an actual person to go and grab and use our backend program to get data off of the websites and then do all this stuff and put it in. It would have been a lot better if we had something that automatically did it, that grabbed it in the background, set all this up, and then displayed it for us. However, just due to time constraints and that, it was not possible, and we found that doing how we actually ended up doing it in the end was the most viable way. Along with having the GUI, which finds the database, needing to change it to the companies in the code. So the companies in the database we'd have to change to specific names, so it wouldn't dynamically grab that either. We saved time, but obviously there were a lot of just quality of life changes that could have come out of this. But in the end, the software did work, and it did provide a consolidated view. But just like all software and all programs out there, there's room for improvement, and we could have done more, but due to just constraints and what we were able to, we were unable to.
So for the infrastructure, some recommendations or improvements that we could have made was our original project only allowed for 6 clients to access our ticketing systems. And this was because we executed this by using VMware Workstation, which slowed down the process of VM creation. So it kind of handcuffed us into only allowing 6 clients because it was just able for us to focus on other areas and conserve time. There is alternatives that we could have used for operating systems such as ESXi or XEN to streamline the creation of the virtual machines while having more control over how they were utilized. With this, we could have actually scaled up the project to where we could have used up to 50 virtual machines to represent our clients, creating something more realistic than just a handful of users.
Moving on to the recommendations for the security aspect of our project. Unfortunately, we missed the opportunity to create and configure an intrusion detection system, and that was, as was mentioned before, unfortunately the Raspberry Pi just wasn't powerful enough to run that efficiently. This was pushed aside due to the lack of time and hardware. We tried to create on the Raspberry Pi, but due to the weak hardware, more specifically the RAM, it was not enough to handle analyzing the network traffic going between our systems. Another security feature that we missed would have been used for the employees accessing the front-end software, which is two-factor authentication. This would ensure that only registered users under our infrastructure could access needed software. The addition of this feature would reduce the risk of unauthorized people gaining access to sensitive company information. And of course, multi-factor authentication was a huge goal that we had in mind at the beginning of this project. And unfortunately, just with a lot of the constraints that we had, there was simply just no time or any resources that went into implementing that. We really didn't have time to even begin the research on it. So it's definitely something that would take, I believe, possibly a month to implement from now on, but it's definitely something that would increase the security and viability, market viability of our project. And now we'll move on to the next section.
So in conclusion, we did create the piece of software that was part of our original scope and part of our deliverables. There are some aspects, as we mentioned previously here, that we just weren't able to accomplish. One major success that we had was obviously with the budget. The original stated budget and the anticipated budget was much higher than what we actually came out with. And if we were able to finish off the remainder of the time and were able to use the hardware which we had set up through the previous weeks, we would have come out with a project that was not only successful, but would meet the scope and deliverables that were stated in the functional spec and the business case. And in terms for the budget, again, we were able to come in a lot lower than what we anticipated, and this was due to the success that we were having throughout the project and making use of the time that we set aside to ensure that we were working productively. And that concludes our presentation. Thank you very much for watching, and we hope you are staying safe and taking care of yourself.
Thank you for watching. I hope you enjoyed.
Thank you.